professional group is an independent group to the ISWA body. And the mission of the young professional group is to make global connection among young people with the aim of sharing knowledge, ideas for improving waste and resource management practices, raise awareness and promote sustainable production, consumption and disposal practices, sharing knowledge and best practices, and also help the young professional to advance in their careers. So I really encourage all of you to join to the young professional group. You are warmly welcome, and you may directly become a member of young professional group of ISWA or join the regional chapter of your country if there is a regional chapter active in your country. So my name is Haniye Jalalipur. I am a postdoc researcher at the University of Rostock in Germany. And I was elected as the vice chair of the young professional group this year. I'm also leading the regional chapter for the Germany. And today I will be moderating this session. We will start the first part of the course with the lecture of Professor Dr. Gerd Morschek, who is a professor in the Department of Waste and Resource Management at the University of Rostock. His lectures covers the topic of sustainable solid waste management, regulation, biological treatment, circular economy, and etc. As the leader of many research projects, he developed technical concepts for aerobic and anaerobic treatment of separately collected bio-waste and also residual waste. On the international level, he has been active in many countries around the world, and Dr. Morschek is an expert in the characterization of waste stream from household and commerce. And he has long experience in waste management projects in developing countries. He developed the procedure for an improved waste value separation and recycling system in China, Southeast Asia, Latin America, the MENA region, and etc. So I give the floor now to Dr. Gerd Morschek, and we will start our session like now it's 8:38. I hope everyone can join. Dr. Morschek, the floor is yours.
So good morning. Can you hear me and see my slide, the first slide? Okay, Hania,
yes.
Everything's okay. So then I can start. Good morning to everyone. You heard something about me. I don't know that I did all this. I can't remember. But good morning and good afternoon to some of you. And welcome to my presentation or lesson or whatever it is. And to some of you, it is like we have on Sunday. Welcome that you take your spare time to join us. Okay, now it works. Okay. I should speak about this, what is written here. A lot of things, and nobody can put this in one lesson. But at the last, I will say to you that you also can use the WasteWise City tool, and I always will compare it or will give an advice to this tool in comparison to this, what I have to speak about. We have to speak about some of the basic of sorting analysis, a little bit about sampling, calculations, one example, we don't have so much time, and so on. Why will we do sorting analysis? I don't want to speak about waste audit because sorting analysis is just a part of all of this. We need 2 or 3 days to speak about waste audit, but one basement is sorting analysis, or the sorting analysis. We need to know something about the composition of waste. Imagine if you want to invest a lot of money, let's say $300 million, to construct a waste, as you say, waste to energy plant. I think it's not the right name. It's an incineration plant. Nobody wants to construct a waste treatment plant to get energy. Waste treatment plants are always treatment plants. And by the way, it is possible to have some energy from this process. If you want to invest a lot of money, then you need to know which waste is coming to the plant. And this we try to fulfill in a sorting analysis, not more. We want to know something about the type of waste, the material groups we have inside the waste coming to our plant, or the waste that we have to collect, to treat, to dump, whatever. We want to need something about the waste, if we could take something out to recycle it, or is it possible to separate something in the households, to collect it separately, maybe. We need to know something about impurities. If we have separate collected material, then maybe we sort only this fraction, and then we need to know how much impurities are inside, and maybe something about particle size. And then, if we are thinking about the treatment plants, we need to know something about chemical and physical properties, of course. Mass, maybe, but we will never have masses from sorting analysis. We need these numbers from the waste management firms, from the county, from the city, or wherever. What we found out is some fractions, which mass have a fraction in the total mass. We need something about water content of the waste in total, or of some fractions. If you are thinking about treatment, water is very important. We need to know something about heating value. If you think about waste to energy plant, loss of ignition, organic fraction, how much organic fraction is inside. Is it possible to separate this material, to make compost, to produce biogas? Then we need to know something about the gas yield, of course. Makes it sense to separate organic waste to produce biogas. If we want to transport waste, then we need to know something about densities in a special case, but not, we will never get it from sorting analysis. We need to know something about pollutants inside the waste, also chemical pollutants, or let's say nutrients, salt, maybe pH value. And this we can find out in the laboratories. But in the beginning, let's say, you always will have a number. You will get a result from a laboratory. But in the laboratories, they don't make mistakes. We make the mistakes by sorting the waste or by taking samples. More than 95% of the mistakes are coming from our side. That's why it's so important to do a good sorting analysis. We have to imagine you have on one side, let's say, a small city like Rostock with 200,000 inhabitants. And then from this 200,000 people, you will take one sample for a laboratory. And this we try to do in a sorting analysis and by taking samples. And now you can imagine that this is not so easy. And at the end, there is an investment. You get a number or a lot of numbers from the laboratories, and then you say to investors, now you can construct your plant and it will work. This is not so easy. There are a lot of regulations how to carry out sorting analysis. You will find in the internet a lot of them. I wrote some here, and you also can use the WasteWise City tool to compare, or also to try to do some sorting analysis. Normally, of course, I use a guideline from Germany, but internationally, you will find a lot of other regulations. They all follow the same idea. In which sectors do we do it? Of course, in residual waste, like we say, because we have a separation system. Municipal solid waste, maybe you will say. Then we also sort in Germany separate collected bio-waste, how to know how much impurities are inside. Also the separate collected packaging we control, and so on. A lot of cases we also control sorting plants. In the beginning, in the input and also in the output, how good such a sorting plant works. And so a lot of cases where you can use sorting analysis. So we have a lot of the waste management basic data are coming from the waste management firms or from the counties. We don't have messes also. We sort the waste. We don't know how much waste is coming every day from the city. We're just interested in the composition of the waste. We test the efficiency of the collection system, the efficiency of the waste treatment plant. If we control the in and the output of such a plant, we can get some knowledge about the usage of the waste containers. In Germany, we collect our waste in containers, not in bags, and so on. You needed to know something about the quality of the separate collected material or the treated material. You then, let's take this, you can look in the future a little bit. How will the composition change in the future if you install separation systems or if you construct treatment plants, maybe? This is very important, and I think nobody, what's this? Nobody do it worldwide. Yearly, all the states worldwide have to write a report to the International Panel on Climate Change, and they also in this have to calculate the emissions coming from their landfills. And when you want to do it, then you need the mass you dump, and you need something about the composition of the waste you dump, and something about the bio-waste or the landfill gas are produced in your landfills. And so if you have a sorting analysis and you know something about the organic you dump, then you can calculate the emissions according to this formula. And maybe this is one case. And of course, as I said, all the sorting analyses are basic for the planning of plants of waste management in common. This is not from me, or I don't know what it is. Anja, is it coming from me, this red one?
No, I think some of the people are trying the whiteboard. Please,
okay.
Audience, stop like using
okay,
the
so
whiteboard
we will
much.
have at the end some of these lines.
And
okay, type of waste. I think we spoke about this, but at the end we have take some samples lately. But when we start to plan our sorting, then we need some random samples. Have in mind, we are taking our city, let's say this small one with only 200,000 inhabitants. Then we have to decide which waste will we take from this city and will sort it. We can't sort 1,000 tons or 10,000 tons or whatever you think. And that's why we need this, we call layering, some subdivisions of the whole waste. We need this layering according to a season, of course. Let's say it's spring or it's winter here in Europe, or maybe in your region it's dry or wet. This is one. And on the other side, this one, we need something according to the income. Let's say the income of the people or how they live. You can imagine if you are quite rich, you produce less or more and other kinds of waste when poor peoples. Or if you live in a village, then you can use organic waste to produce your own compost. Or you can use kitchen waste to feed animals also. And that's why we need different layers and take samples from these different income areas, from different housings, from different seasons. We will see it later how it works. here's something about this, urban and building density. It's combined with the income often. Then do you have houses or apartment buildings, the size of the houses, something about waste bins, if you have them, sizes, different sizes of waste bins, and so on. Have you a separate collecting system nearby? So it is interesting what is in the remaining rest. Income, I mentioned, economic structure, of course. We are here living in tourist area, and so it's important. Then the tourists are here in summer. We have different composition of waste than now in the winter time, of course, when the tourists are not here. Type of heating may be important. Have you ashes in the winter time? And so we have 3 to 5 layers, different layers. We will see what I mean. We have layers in the season. Normally here in Central Europe, we have 4 seasons. Or if you have 2 seasons, like rainy seasons or dry season, then of course you have to collect in dry and in rainy season. It's not only the water content what changes over these seasons, maybe other things. And housing in Central Europe, we have 3 to 5 different housing structures. Normally, I prefer to have 4 different structures. We will see pictures, what I mean. We have the center of cities, urban structures, the suburbs or small towns, and also villages. And if you know, in villages, they have animals, or where they have enough space to produce their own compost, then maybe the remaining municipal solid waste is different from the waste if you have only an apartment and you are not able to feed animals or to produce compost. Maybe you're richer, you have more packaging, and so on. And that's why we need different layers or different housing structures. For example, it can mean, this is one example here from Germany. We have chosen in this case 4 structures. They got a name, and then we have cities with houses or blocks, apartment houses, the suburbs and the villages. And so we have different structures, huge houses, or you have your own house for 1 or 2 families. And compared with this in Germany, we have different collection systems. Huge houses, apartment houses, they have huge containers. We have more than 1 cubic meter. Or if you have your own house, maybe you have very small containers in the front of your house. And so you also will find differences. So we have 4 different, in this case, in Germany, we often choose 4 development structures. And then additional, of course, we do it in different seasons. We have not only 1 sorting, maybe we have 1 in summer, where we have more organic waste, more green waste, and we do minimum 1 in winter. Normally, we try to have 4 in each season. These are examples for these building structures, just to show it. You know it. These are pictures from Germany, of course, but you can find similar pictures from your hometown. These are the suburbs, maybe, and maybe in Germany you have the same structure in villages. We don't have these huge differences between villages and cities like you see worldwide. We have nearly everywhere the same living conditions if you live in a village or in a city, but the housing system is totally different. And you see here small containers, they are only for 60 liters. And maybe you can imagine if you live in this house or in this, that you have different kinds of waste. You have a garden and so on. Like this, just to see it, these are the huge containers, the small containers. And so maybe you have different wastes inside different composition. When we try to get our samples from these houses, and we have to decide where it is, then we always have to choose the same time when the waste management firm is emptying the container or collecting the bags, not on another day. We take the same day. Otherwise, we don't have waste, or we don't have all the waste they produced in the last time. No extra days, please. From normal days, of course, we need something about the volume of our containers in advance, or of the bags you have. You often have bag collecting systems. All our samples must similar to the reality. And I think you know this is not so easy, but at the end we have to try it because of the investment, the following investment. In the beginning, we think about the cities, villages, or regions where we try to take our samples. And this you can decide only together with the waste management firms. They know where are the containers, how do people live. There you will find a normal composition of waste for this housing structure. And something about statistics. You can think some days about statistic, and you can find a lot of things how to calculate how much samples do you have to take. You also can find something in the Waste-Wide Cities tool, of course, and you can calculate a lot of this. I try to take this one, and at the end, it means we take 48 cubic meter for one sorting analysis. I don't have enough time to explain this a little bit better. And at the end, you have to sort this. That means you need waste densities just to know how much tons in mass now, the tons I have to sort. And then you have to compare it also with the Waste-Wide City tool, something about density. These are densities we have here in Germany. In the Waste-Wide City tool, you'll find densities, I don't know where it comes from, the numbers. I don't think that anyone has this density you will find in the Waste-Wide City tool. That means you have to think about the density. Maybe, by the way, you have to find out which density do you have. Now let's speak about technical requirements and, of course, of the stuff. What do we need? A place where we sort, of course. That means protected from sun or rain or wind or snow or whatever. You often need electricity for your balancers. You need light. You need a truck to transport the waste. That means you always need to cooperate with the waste management firms, with the city or the county. Normally, we don't go as university and say, now we have to sort some waste. We do it together with cities, with waste management firms. Otherwise, it will never work. We need the containers to sort on the side. Of course, we will see some more pictures to understand it. For our sorted out fractions, we need a lot of containers. And so if you cooperate with the waste management firms and you use where we are, the place where we are, then you can use their containers. In Germany, we have another technology than worldwide. We don't sort the whole waste. We screen the waste. And we screen with a 40 millimeter screen and a 10 millimeter screen. And then we sort out the fraction larger than 40 millimeters and make some analysis with the other two fractions we have. We don't sort all this because if you have a lot of minerals, a lot of sand or ashes inside your waste, how to sort this fine fraction. And so we decided in the past to sort only the fraction by hand, larger than 40 millimeters. We need tables to sort, or belts if we have. Of course, we have to move the waste. Then we need wheel loader, shovels. We need, let's say, magnets to test if it is magnetic or not for the sorting process. A lot of balances, because if we sort out something, the input is, we have to weigh the input, we have to weigh all the sorted out fractions, we have to weigh our samples, and so on. We need containers for the samples, small containers now, to bring our samples to the laboratory. Labels, protocols, cameras, shovels, and so on we need, and we need working safety equipment. It's very, very important. Waste, let's say in the beginning, waste sorting is not dangerous. You have contact to the waste, of course, and where are some people, they can't do it. They don't want to do it, and then it's okay, then they can't sort. But it's not dangerous, you can do it. But you need some health and safety things to sort, and we will see something. There are some slides. I will skip this. You are endangered, of course, because you have direct contact to the waste. You need to be vaccinated. Please do it. Think about this. And you need special clothing, equipment. Let's see this on a slide, and you also will find something in the Waste White Cities tool also. Of course, we need gloves, we need shoes, masks, overalls, and so on, of course, for the sorting process. Now let's go to the waste sorting in an example. Maybe it's the best. The first step will be the waste is coming. Sometimes we are going with the waste management firm, or one of us is going with the waste management firm, just to know that they load the right containers, not other waste. They have to bring the waste we have chosen to separate to us. You have to cut the waste bags. You have to open them because you need to know what is inside and to sort. Then we start screening. We will see some pictures later. And we sort only the fraction over 40 millimeters. Sorting by hand, of course, is necessary. Positive sorting, that means one people is sorting one fraction, or normally one people is sorting 3 fractions. He's looking for 3 different fractions to sort them out. Sorting capacity, what can you sort per person? I think more than 100 kilo per person and day is not possible. You can read whatever you want, but if you did it, if you sort waste by yourself, you will learn you are not able to sort 800 kilos. It's not possible. And you can't sort waste for 10 hours. It's also not possible because it's waste. You should do it, and then you know what I mean. The fraction between 0 and 40 millimeters, of course, sometimes we sort, we will see it, and we also take samples from this fraction. We have to weigh all our sorted out. We have to weigh the incoming waste, of course. We have to weigh all the fractions. We have to write down what we have. We have to take samples. We will see how we try to do it. Let's see one example we did in the last years. It's a county in the state where I live now. You can compare it with the Waste White City tool, of course. We have the housing structure. We spoke about this. We have chosen 4 different structures, different kinds of cities, as I said, and different kinds of containers they have there. And we have different living conditions. In the small towns or villages, of course, they produce their own compost. Some of them do it. We have home composting systems. Some of them feed some animals with kitchen waste. And they, in the housing blocks, they can do it. So we have one of these counties, not so much people in this example, because we are living, Germany is a federal state and we are living in the northeast of Germany, and not so much people are living here. They are mainly tourist areas. We have a lot of lakes and not so much people here. This may be the county we have to check. And now you have to think about the fact, where are the cities? Where do the people live in these block houses? In some cities, in the larger cities they do. And where are villages? And which of these many villages they have in this region we choose to take our waste from there to sort it. And there was a planning in the beginning to find out which of the village or which of the smaller cities are representing all the other cities. And this also always took place with the help of the waste management firms. They know something about the waste, and together with the government of the county, just to have such a plan where we take our waste samples, the waste for sorting. And then, as I said in the beginning, we need minimum 12 cubic meter or 12 cubic meter for sorting process. And then we planned for different, these are the housings, different housings, 1, 2, 3, and 4, and how much samples or how much waste we have to take from this. And these are the containers they have and how often the containers are emptied. And at the end, we always took much more when this 12 cubic meter, we take 10 times of the 12 cubic meter just to be sure. And then at the place where we sort, we decide, or we mixed the waste, and then we decide, okay, we are not able to sort more than 100 cubic meter and reduced the volume at the site where we sorted. So it starts in the morning, the waste comes to the place. It's a protected area owned by a waste management firm. Of course, you have to open the bags in the beginning, otherwise how to sort, it's not possible. And this is the idea we follow. The waste is coming in, we open the bags, and then at first a screening process starts with 40 millimeters, of course, and the coarse fraction is sorted by hand, this line. And then the fraction smaller, when 40 millimeters, is screened once again, now with a 10 millimeter screen. So we do it in Germany. A lot of countries don't screen the waste prior to sorting. And then we have a middle fraction between 10 and 40 and a small fraction. We always take samples for the laboratories. We want to know something about all these sorted out fractions, but we also need to know something about the screened out waste, because at the end we need to know something about the whole waste from different housing structures on one side and from different reasons, of course. So at the end we have a lot of numbers and a lot of knowledge. And keep in mind, we want to know, is it possible to run an incineration plant, for example? Not in this case, but normally you're doing this because of waste incineration plants worldwide. Always analytic. We want to know what is in this fraction 10 to 40 and also smaller than 10. 10 to 40 also by a simple sorting process. We will see, maybe we want to know how much organic is inside. Or in the fine fraction, we want to know, just to know how much ashes or minerals are inside, not more, because we are not able to sort fractions smaller than 10 millimeters. These are screens, maybe you know this, a drum screen. So it is screened 40 millimeters, the fraction, this is the fraction smaller than 40 millimeters and is going completely to the 10 millimeter screening. And these are the fraction larger than 40 millimeters. And this we have to sort by hand. Second screening, now we have a fraction smaller than 10 millimeters and the fraction 10 to 40 millimeters. We have to sort just to know how much organic is inside. In this case, we want to know how much organic is inside because the waste management firm and the county want to decide, makes it sense to have a better collection system to get more organic material for a compost plant. If you don't have a screen, a mechanical screen, then I think it's a problem. Then you need your own screen from your laboratory, like we have here at the university. It's not so easy than these technical screens, of course. You need much more time. It's much more work to do. And so we try to sort only if we have this mechanical screens. But it is possible to screen it like this in a machine to screen it, like we can see it here on the right side. And this is the results. We have the fraction smaller than 10 millimeters. You see a lot of minerals, also some organics. This is the fraction 10 to 40. In this case, a lot of organic inside. Some more of these pictures. Then you can sort. And as I said, we normally sort only the fraction larger than 40 millimeters. You can do it on a table like this, or later we can see also you can do it on a belt. And so you need a lot of containers. We will see which fraction we sort, and so everybody sort out some fraction and put it in these containers, and at the end we can weigh what we have inside the containers, and we also can take samples. You need a lot of space. You need also places where the people can have a shower at the end, and so on. You can't do it on a landfill. You need a good place for the sorters. If you have a sorting belt, then maybe you can use it, like you can see here or here. You also see the containers here. So this is for paper. Just we sort out paper and put it in this container. Okay. I want to skip this, but you can imagine how it works. It's not the best work, but it's possible to do it. What do we sort out? Also in the tool, you can find something. Normally, we take these fractions. In Germany, we have different levels. We will see it. Organic waste, paper, glass, plastics, textiles, ferromagnetic metals, non-ferrous metals, wood, composite materials, harmful substances. Some things we don't know what it is, which fraction it has to go. Then minerals, hygienic material, and then our fraction we have here in Germany, 10 to 40 or 0 to 10. And then we have this. In Germany, we have 3 different levels. The first is, let's see this only organic. And then the second differentiation may be kitchen waste. This is more the wet food material, and garden waste. This is more or less green waste with more wood inside, of course. And as you know, there is a difference between kitchen waste and green waste. Kitchen waste is good for digestion systems. You can produce biogas out of kitchen waste, but you're not able to produce biogas out of garden waste, but you can use it in composting systems. And maybe there is a third level. Nobody thought it, but you can do it if you want, and nobody's interested in this. Normally, I thought only the first level, only the organic. I have kitchen waste and garden waste. Let's see the other ones. Paper and cardboard, of course, and maybe your mache ich dir später. And maybe you are interested in what is packaging or what on newspapers maybe. But normally we thought only one fraction paper, cardboard packaging. You need more time, more staff, more money to do this. Paper. We have seen, and always you can have a second level if you want to do it. If you're interested in packaging. It's more interesting in Germany because we have a special system to take back packaging, and so on and on. I will skip this. Textiles. We often have shoes in the textiles. Some sorters have the shoes in the composite materials, wood, metals, packaging, harmful substances. These are batteries, medicine, drugs, and all these oil containers, and so on. And we need to know how much of these substances are in our waste, because if we dump this all together, then we will harm the groundwater. And that's why it's important also to know how much of these substances are inside. What we don't know normally is leather, some rubber, or whatever you want. Hygienic material is very important because this is wet, and it's interesting because of hygienic aspects to know what it is. And at the end, of course, in Germany, the screened out fractions. These are the fractions once again, and now some pictures just to know what it is. I don't know if you have seen so much waste, then you should do it. This is kitchen and garden waste mixed. How we sorted out the material, or you can sort out all the other things, and at the end you have the remaining rest is the mixed kitchen and garden waste. Hygienic material, in Germany we have quite a lot of this inside the waste. Plastics, plastic packaging, ferro, metals, in this case mainly packaging, composite packaging, textiles, shoes this is the composites. We sort out shoes normally as textiles, but as you see in this case, the sorter don't remember this, and he put shoes in the composite material, and maybe you have to control the fraction after the sorting process. Because the sorter not always remember, they make some mistakes, and waste is just waste. It stinks, and so some of the materials don't go to the right container. And at the end, you control it shortly, but normally they know what to do. Composite material, some people sort also out electric and electronic waste. You can also choose this as a fraction. These are harmful substances, paper and cardboard, mainly aluminium here, minerals, not glass, because glass we have a separate fraction. These are china and stones and all these textiles. And at the end, we have to weigh all our fractions, of course, just to know what is inside the container. You know, not the container himself is interesting, what is inside. And now we have to take samples for the laboratories. How to do it? We have a volume. We have one volume or one mass in our county. A lot of waste. Then we have chosen some samples for the sorting process. And now we have to take small samples for the laboratory. And that means our sample that we bring to the laboratory should have the same composition like we found in the whole city with 200,000 or much more inhabitants. And that this is not so easy, I try to explain here. How much material we have to take depends on the grain size of our material, where we have to take the samples, of course. We produce a laboratory sample out of larger samples we took from the waste. We will see it on one of the picture. We need a lot of sampling containers. They must be clean. And we have to transport the samples to the laboratory, cool if possible, cooled quickly, and not on the last day of the week. We have to speak with the laboratory. When do you want to have the samples? We have to cool them, which amount of material you need for your analysis, and so on. You also have to speak with the laboratory, and they need to know where are the samples coming from. Just to speak, you always have to speak with everyone, with waste management firms, with laboratories, and so on. Then worldwide, you will find different regulations, how much samples you have to take, which mass or which volume do you have to take. This is one from Germany. And so maybe we take this, we have this structure, and so at the end, let's say 2 liters we have to take, and minimum, this is one sample, and then we have to mix these small samples to one laboratory sample, like this. We will see it. We have, I think, 4 different ways, or 4 different, no, 1, 2, 3 ways are possible to take our samples or to get good results. In the beginning, we need to know that the waste is very inhomogeneous, of course. We need a representative sample, and it shows us a mix of the waste of the whole city, and just to have it always in mind. And I think you can go 3 different ways, and all of these ways will work to take a sample. One, maybe you take a large sample from the sorted out material. Let's say we want to know the composition of our waste, and we have the possibility to take samples from the mixed waste. Then, if you can do it, then you can crush all the waste, a lot of tons of this, and when you can take, after crushing, several times crushing and several times quartering, we will see what it is, you can take your laboratory sample. Another technology I prefer is you take samples from each fraction you have sorted out. So you have paper, let's say you have paper, plastic, and so on. And then you take sample from the paper and from the plastic and all the other one. You can crush it, only this sample, only the paper. And so you take your sample for the laboratory, and at the end, you calculate your incoming waste by knowing something about the different fractions. And I can explain it later. The next slide will show it on a picture. And there is another possibility. You take small samples from each fraction, combine it together, and then bring this mixed fraction to the laboratory. Just to know what I mean. At first, we have to take our sample, let's say from the whole waste, incoming waste. This could be number one, from all the waste, or the same as we take it from the paper or from the plastic. Then we have to think about it. Is it okay to take one sample from here and bring it to a laboratory, or we take it from here, from the top? It will never work, because if you have such a small heap, a small mountain of waste, then you will see, or you always see it with food, with different kinds of foods, that you have the coarser material on the top, and the finer material, of course, if you have a lot of minerals or ashes in the waste, you will find it on the first layer, on the ground of the material. And so you take your sample all over your heap or small mountain, whatever you have. If you have these piles, then of course always over the whole body of your material, not only from the outside or from the top or from the ground, you should take a sample from all the heap or small mountains you have. Then you, in the beginning, you have one of your sample from all over the waste. It's much too much to bring it to the laboratory. And then following is this quartering. They call it quartering. You take this small mountain, put it into 4 quarters, take the opposite quarters, make it to the next mixed sample, and repeat it. And at the end, you have one sample from this huge mountain of incoming waste or of sorted out waste. The first means, just to know what I mean, you have the whole waste, what came into your sorting place. You have the possibility to shred all these material. Normally, this is not possible, but sometimes it is possible. And at the end, you have a mix of everything, of the incoming waste shredded, and then you know this is easier to take a sample according this quartering method than here. How to take a sample from this mixed waste by quartering, it will never work. But this, as you can see, oh, I think you can see, it's easier to take a sample. The other technology I prefer is the sorted out. These are the sorted out fractions, like kitchen waste, or let's say this fraction 10 to 40 millimeters. We have it, and then we take a sample from this, and so at the end we have this 14 or 15 samples. We shred all these samples in a laboratory, so we need a lot of things to transport to our laboratory. We shred it, so at the end we have samples from all these fractions, a lot of samples, and at the end we calculate 40% of 10 to 40 millimeters, and so the results of the analytics will calculate in the mixed waste calculation. We will have one table, or this is also possible. We take samples, put it together to one sample and shred all together. This also works. I prefer this method. So I have 40 to 16 different fractions. We know something about diffraction, about all the fractions. I know something about hygienic material. I know something about kitchen waste, about the fine fractions, and mix it together in my mind. This, I think, it's easier and better to do. Why we take samples, I explained in the beginning. Example 1, just to show it to you what we did. These are the fractions we took, not all the fractions, it's just an example. And we know we sorted out the material. Let's say organic waste was 62%. We took our sample. Now we know something about the water content. And so we know it from all the other fractions. This is not complete. And then we calculate the water content of each fraction and how much of the mass is coming from the fraction. Let's see this, 62.1%, and this is 70.5 water content. That means the first calculation is 6 to 1%, and 705 was the water content, and now all the other fractions are following. And so overall, we have a water content of 55.6%. Sorry, we don't have all the time to explain it once again, but I think you can understand what I mean. The same we do with the lower heating value. We have taken samples, and in the laboratory now they can estimate the heating values. And so we now have the results. One point is interesting. If you're looking in the internet, what is the heating value, the higher heating value in this case of plastic, then you not find 29 megajoule per kilogram dry mass, of course. But we have plastic full of dirt on the plastic. Please never use these heating values you will find in the internet. They always are mostly coming from fresh material. If you take newspapers, these are the same problem. Dirty the material, so you have a lot of minerals on both sides of such a sheet, and so the heating value is reduced, of course. That's why you need to know something about heating values. You can calculate heating values also. We don't want to show it here, but you need not every laboratory can do this. You need a calorimeter to know something about heating value, if they can do it. And at the end, we calculate from the higher heating value, also the lower heating values. We have, this is the calculated mixed higher heating value. And now we have the problem that we have a lot of water in our waste. And at the end, we have a lower heating value, much lower than the higher heating value. I think you will know it. The calculations are always following the same process we have seen some slides before. Presentation. Now what we have seen from our example, we have the housing structures, the blocks and the villages. And what you can see, we have different numbers for all these structures. This is what we want to know at the end. In our case, in the beginning, I said also the 10 to 40 millimeter fraction is sorted out. In this case, just to know how much organic is inside and this fraction, that means these are all organic. We could collect if there is a collecting system. These are not organic material. And we have to know it. On one side, we have the sorted out coarse fraction, larger than 40 millimeters, the organic. And now additional, we have this fraction coming from 10 to 40 millimeters. That means we sorted out green and kitchen waste, 10, 11, 14%. And we also found a lot of organic, these are the fraction 10 to 40. And we found a lot of, let's say here, 34% inside this fraction. And additional, we have organic fraction of this correct way. That means this is only the coarse material, and additional we have, this is coming from the fraction 10 to 40 millimeters. That means we have not only this 10% of organic waste inside the mixed waste, we have nearly 40% of organic waste. These are the same, just 8% of kitchen waste in building structure number 4 in this example, and adding the organic material coming from this fraction, the yellow fraction, adding to the blue fraction, at the end we have nearly 40% inside the fraction. This shows the same in columns, the differences between different housing structures. More or less plastics, more or less organic waste in different housing structures. If you want to know how much biogas we are going to the end, you can produce from the organic waste. Then you have to take samples from the organic waste, of course, and do tests in a laboratory, like a lot of universities can do this. In this case, we know in this county, they don't separate so good their organic waste. And so after the sorting analysis, you can say, okay, if you sort out your organic material in a better way, then you can produce from each kilogram you collect separately, you can produce this amount of biogas. And at the end, if you know you sort out 10,000 tons per year, then you can produce this amount of biogas containing a lot of methane, and you can produce at the end so much energy from the separate collected organic waste. Maybe that's why you do a sorting analysis, just to show how much energy you can produce by producing biogas. Makes it sense to install a separate collection system for bio-waste. Now, I don't know what I want to show here. I forgot it, what it is. The biogas yield is different over the different fractions, of course, in the kitchen waste and also in the fraction between 10 and 40 millimeters. Of course, you have a good yield of biogas you can find out. And as you know, only from the organic fraction you can produce biogas. But in this case, you can say to the county government and to the waste management firms, please think about to install a separate collection system for organic waste, and then you can produce biogas to get energy, or please collect the material and construct a composting plant just to produce compost. So you have the fertilizer and the humus to bring it to your farmland. Summary, maybe the last slide. And so we are just in time. Just to say, we always have results. Whatever we do, there will be a result. But it's important, can you trust your results? Have you taken the right samples, or have you chosen the right regions, the right village, the right quarter in your city to take samples, to sort it out? You always have to think about this. because at the end, someone wants to invest a lot of money and he wants to know if the waste burns really, or can I produce enough biogas from my waste so that I have some income, and so on. And once again, we make the mistakes, not the laboratory. That's why we always have to think about what we are doing on the sorting place. And we have to represent the housing structure and also all these changes over the year. And I think this is all. Thank you very much for your attention. Hanya, I think I'm just in time. We need normally the presentation is much longer. Normally, also the calculation is better and longer, but normally it takes 3 hours, and so we have one just to see something about sorting analysis. Thank you very much.
Thank you very much, Dr. Marshek, for your informative presentation. So far, we had a very fruitful session, and 100 people in the Zoom, and the rest are on the live stream. For the participant, I just want to note that for getting the certificate, because there was a lot of question in the chat, please note that apart from participating in the 2 days sessions, you will receive a small assignment per email, and you have to answer the assignment which are from the presentation to get the certificate. And we had a lot of questions in the chat. I will start to go through the chat. If anyone wants to ask the question, feel free to open your mic and ask. Otherwise, I will start to ask the question. Anybody wants to ask the question? Okay, I don't hear anything. So the first question, Dr. Morshak, we had like several time question about the source to take the samples. Is it, how does it matter to take the samples? Some ask that, for example, should we take the samples from doors to doors, or should we take the samples in the disposal facility, in the MRF, in the MBT, or in the landfill? What is the difference between them, and which one is suggested to take the sample?
I think both things are possible. We decided where to take our sample. Let's say we decide we take it in this blocks area with huge houses. Then we can take the sample there. We always need to know that we just have samples from this site. That means if there is one truck only collecting on, I don't know, every Monday in this region and only in this region, not in another region, and then this truck is going to a dump site or a treatment plant, then I know inside the truck is only waste from the chosen area. Then I can take this one, of course. But I always need to be sure that the material comes only from my chosen territory and not from another place. That's why always the cooperation with the waste management firm. We also do this. We have often 2 cars. They take out, sometimes we take what we want from this street, and they bring on us just the waste from this street. The truck is not totally or fully loaded, and then there is another truck taking all the other waste, bring it to the treatment plant or to the dump site, and we so have our truck with our samples. This may be 3 or 4 cubic meters. Both things are possible, but we need to know where the waste is coming from. Not any waste. They bring us always waste, but we need to wait to know where it comes from.
Thank you. And maybe also you answered this question, because someone asked that for city like Bangkok or in Thailand, there is no bins, and like the waste is collected without bins.
The same works with bags. As you know, I don't know if you sort every day. Maybe some are collecting every day. Then you should decide, okay, on Monday we always will take our samples on Mondays, and we will take this road because we think this road shows the same structure like 1,000 other roads in our city. We take always this road. They don't know it. The inhabitants don't know it. And so for the next years, we always will take the samples from this road. And so we collect the bags and bring it to the sorting place. No bags from other streets. We take this road, and we will take our samples for sorting always from this road, because we think this represents 1,000 other streets. And now you can say, okay, why don't you take the next road and this road? Who knows? But if it represents, and I think the waste management firms, and if you live in this city, you know that this road is like the other roads, and let's take this road. I don't know why. We have the same structure. We have the same amount of small shops or of restaurants like you have in the next road. And then let's take this road.
And what is like the intervals? Maybe is there any standards intervals for taking sampling and waste characterization? Let's say
worldwide you will find a lot of them. Now I have chosen German ones, of course.
No, the intervals, like how many times should we take samples during a year, for example, or should we, like, let's say every 5 years taking samples?
No, this doesn't exist. Because it costs a lot of money. This is always a problem.
And how much does it cost? It's also a question from YouTube. People feel free to ask also in the YouTube. We are
but there's no regulation to say you have to do it every 5 years.
And how much does it cost each time? Is there a specification?
We can't speak about costs, because in Germany we have other costs than in other countries. But you have to calculate: is the transportation for free? Because waste management firm will do it. So you need sorter, you need a place, you need laboratories, and so on. And so you can try to calculate your own costs. But it costs nothing in comparison to the investment of a waste treatment plant.
And so in case of developing countries, if we have to go to landfill and take a sample from landfill, how to manage to take a representative sample from landfill?
And not directly from the landfill. Now I skip this. My screen is shared. This is a sorting analysis in South Asia. Let's see this. There's a truck coming, but we decided where the trucks comes from. This is not a mixed waste all over a city. We have chosen together with the authorities 1 or 2 or 3 streets where we took our sample, and then they load a truck. Normally, let's say maybe this is Monday, with the waste they collect on all Mondays, but only from these 3 small streets. Then they bring it to the landfill. This is not the normal waste they dump. The dump site is, I think, let's say 500 meters away from this place. And so we started to screen, very, very simple, because this is middle in the nowhere, and start to sort with help of these people on the landfill, but not the mixed waste coming from anywhere. We don't know. This is the waste where we know where it comes from the city, from village. So we had, I don't know, 3 or 4 different sites chosen.
So maybe I ask the last question, and if we want to have a representative sample to plan for a waste management plan, so And in case there is different season, how many samples should be taken? Like, is it, should we take different samples in different season? How does it work?
Different samples in different reasons?
Like,
No,
should we repeat our sampling in different season of the year?
Yes, let's say in this case, in wet and dry season, if we are in South Asia, and then from the same side, from the same streets, because
So,
there will be a different. Let's say because of the water content. Or I don't know, but here in Germany, because the water inside, the consumption, the season, the tourists, or whatever you have, and that's why you need different samples. And then at the end, you have to decide. We have 3 months with the tourists and 9 months without tourists. And so you can't calculate 9 months like 3 months at the end. So, but we never speak about masses. We always speak about the composition. We don't know something about the mass of waste we have. This is the knowledge of the waste management firms. And we have to combine it at the end, the mass with the composition.
So in other words, we should consider the geographical condition of the study area, which includes the weather condition, the tourism, and etc., to define our intervals for sampling before planning for a waste management plan.
Let's say in this case, we had a total crazy thing. Normally, you produce a lot of food waste, a lot of organic waste. But this was in a region I don't want to mention. The people has been very, very poor, and we don't found any food waste there. Totally crazy. All the other studies worldwide found a lot of food waste, but they have been so poor that they used all the food waste to feed animals or to produce their own compost. And so there was no food waste on the dump site, nothing. Only this green waste, something for the elephants to feed them.
So thank you very much. We are a little bit over time. Thank you, everyone. And we will answer the other question. We will collect the question in the chat and ask from our presenter. Please feel free also to ask question in the YouTube channel. We are collecting the question there. Now we will have 10 minutes, less than 10 minutes, because our next presentation will start like, okay. So let's have only 2 minutes break and come back 9:55 to start with Dr. Mansour. So 2 minutes break, and then I will leave the floor to Maria Yapian for moderating the next session. Thank you, everyone.
I believe, Hania, you are able to put the next slide.
Yeah, sure. Just
perfect. So we start in just a few seconds. Alrighty, let's start up. Yeah, so hello from my side. Hello from very snowy and wintry Finland. I will be the moderator of this session. My name is Maria Yappinen, and I am coming as I think it's on this side, is there from the lab, University of Applied Sciences. We are 2 campuses based in Lahti and Lappeenranta. And actually speaking, I am working in the research development and innovation as a specialist and a project manager for 2 projects, which are related to waste textile and another with the furniture textile. And shortly, not shortly, a little bit about the lab, that we do have a bachelor's and master's programs. We do have a English courses in English and we are quite strong in the circular economy field. And related to the young professionals group and everyone who is from Finland listening, just a little note that we are also a young professional group in Finland. And I think I will be putting later on in the chat a link to that. So we are very active here. I will be keeping time today, and everyone please be alert. There will be assignments throughout this next session. And we have this session around 1 hour, and then we are closing up with a Q&A. So if you have questions, do put on them on YouTube a question part or in the chat of this Zoom link. But without further ado, I would like to introduce a very, very special person here who has a 35 years international experience, Dr. Mansour, and he's currently a theme lead on waste burning program at the Royal Academy of Engineering in United Kingdom. So he has tons of experience to share, and so the screen is yours. So please, Dr. Mansour.
Thank you, Maria. Thank you, everybody. Can you hear me all right?
Yeah.
Yes.
Okay. Yeah. So thanks for this opportunity, and I'm really excited about this topic because what we call I designed this as a learning together session, so it will be quite participatory, and I will be sharing what I learned, but also I will be sharing with you my questions. And my frustration, and especially because this is a group of young professionals, I would like to throw some of the challenges to you so we can work together. You can work together, I can work together, and we all work together to move the situation from where it is. I will be talking more or less about developing countries. I worked in more than 20 countries, and in some cities, the data I generated on assignments was collected first time. So obviously it was a start of the process. And when I started my own career, I faced many challenges in waste composition, quantities analysis, and throughout till now, I have lots of questions and concerns. But also I would like to share my learning. So the way it is designed, I will be taking not more than 20-25 minutes, including one participatory session. And then we have some questions on the slides, and you will receive some questions, which I think you can submit for your certificate. So let's start. There will be lots of time for discussion, and I'm running another session tomorrow. Some of the questions you are asking, we will be talking a bit about that tomorrow as well. So please stay tuned and remain in touch. Thank you. So can we have the first slide, please? Thanks.
Yeah. You see the slide?
Yeah,
Yes.
yeah, good.
Okay.
Yeah. So as I said, this session is more about my concerns and frustration, especially about the data and composition and waste statistics till now. I work quite a lot with many donors and many governments, and throughout my engagement, I feel this is one of the weakest links in the waste sector. And even to some governments or donors, I'm talking about a special challenge fund about some of the failures, like Gates Foundation has a failure challenge fund on on-site sanitation. I'm convincing them to have a failure fund on waste sampling, because it doesn't make common sense, but there are a few things which we can learn together, and there are lots of challenges you can handle. So if you go to the next slide. So for a waste management feasibility study or city level understanding or even community-based projects, we have some key indicators. And if you see waste publications, you will be looking at some of these indicators. So commonly these are generation rates, which are how much every person generate every day. Another one is the physical composition of from the mixed waste, how much of the percentage of each material. Another common one is the bulk density. What is the mass or weight of a cubic meter of waste, and the other is the moisture percentages. In some cases, we go for chemical composition and others. Now, I'm not going into the details about from where these standards are coming, but we will be picking up tomorrow some of this, what the history or sources of some of these standards. So one of the things, if you read global publications, feasibility studies, project proposals, in many cases, sometimes the key information is missing, as Professor Marshak also highlighted, touched on those issues. So in many cases, the sampling point is not there. So if you do the sampling at door or at the bins, which are common in many developing countries, or at a transfer point, or a disposal site, or a dumping site, the waste varies quite a lot in these places, because new streams enter, old streams taken away by waste pickers or small private sector. And in many cases, the sampling point is not there. The size of the sample, the seasons of the sample you already touched, and number of those key details are missing. So one of the things is, when you see any data and these things are not there, immediately ask the question, because to have a meaningful data set, you need to explain it clearly, because it will lead to very big investments, and it may lead to many big decisions. And many countries, governments are even not aware that data can be collected and can be used. So it's a situation where we can all work. So one of the things which I would like to focus and share with you is these data sets has a history. Some of it comes from the why we are collecting this data and not other data. Some of it comes from the water sector, which is quite established and older than waste management sampling. Some of it comes from the soil sector, the geology and the soil sector, and some of it comes from other sciences which are more established. So the reasoning behind why we are collecting some data and why we are not collecting some other data is also very important. And that is, when you do any assignment, the purpose of the assignment needs to be very clear. Don't just pick up standard parameters which are in other publications, but think yourself, why I need this data and the depth of the data required. So a lot of this data is collected. The key purpose, in my opinion, is about waste system development, procurement of the vehicles and machinery, container sizes, and selection of the landfill sites, right? So at the city level, these are the key decisions which we expect to take based on this data. So this is the situation, current situation, in my opinion, right? If you go to the next slide. Now, this is a simple exercise. You can write your answers in the chat box, or you can, in some cases, you can make your notes and share with the organizers. So I'm asking you this question, and I will give you 3 minutes. That suppose you are designing a recycling program for a city of population 200,000. What data you will need and why? Please make your notes, and you may be asked to take a photo of the notes or take a screenshot if you're typing, or some of you may write in the chat to build the discussion. So this is a recycling program, which let's assume it will recycle paper, plastics, and glass. And what data you will need and why you need some data. So pick up a couple of examples, think about it in 3 minutes, and make your notes, and we will start a discussion. So now there's a pause of 3 minutes, so you can think about it and complete your exercise. Is the exercise is clear to you or it's not clear? You can unmute and ask if it's not clear to you. Okay, I assume it's clear. So let's move on. Thank you.
Dr. Mansour, maybe I ask a question.
Yeah,
So
please.
it's a city of 200,000 inhabitants. Is it in a developing country or
Yes.
in a?
Yeah, let's assume, you can assume it's in a developing country, but the issue equally right for developed countries. So in a developing country, it's a city of 200,000 and you are designing a recycling program. That's the question, yeah. Okay, so we start your time now because it's building up the discussion. So you can write your notes now. Thanks.
If you are not able to write, then you feel free to post a picture of your notes in the chat. Dr. Mansour, I'm not sure if you are able to see the question from Joe Huang. He's asking about demographic in terms of income level, building types, type, space use, waste characterization. Are you able to see that question?
I thought he shared notes that this is a set of data. Yeah. I'm
right.
looking at the chat. That's fine.
Thank you.
Good. Yeah, we have another half a minute left now. There's excellent notes coming up. Those who are sharing the screen, can you make it a bit bigger? I can't read it, but it seems like something very interesting. Right. Yeah, a few more notes. If you can write, that would be great. I think time is almost up now.
Do you please still put your notes if the time has now run out? we will be very curious to read.
Excellent, very good. Yeah, no, the good notes. You can keep sharing and keep your notes with you for the certificate. Organizers may ask you to submit some of the notes, but some very good stuff coming in. Anybody would like to share? Anybody is very excited about this question? You can unmute and share. We can take only maybe one response and to build up the discussion. Anybody who would like to share their response or answers?
Yeah.
Go ahead, please share your name as well. Thanks. I can't hear anybody. Is there anybody who would like to share any of the responses?
I
Hi,
can't
sir.
hear either.
Hi, sir. Am I audible?
Yes,
hi, sir.
Faisal. Go ahead, please. Yeah.
Yeah, so my name is Vishnu. So I am from India. So as per your question, like in a 2 lakh population in area, so when we have to start a recycling program in that city, which I think will be not having like a legacy of recycling facilities or anything like that. So from my experience or perspective, like so we have to understand the demography of that area, like if it is how many households are there, like high income households, middle income, low income, and and we have to, with the help of a purposive sampling, we have to demarcate the according to the population, and we have to take the waste composition from those households, and so that we will be understanding how much what type of waste we will be producing from that city. According to that, how the tons per day capacity MRF facility or any recycling facility we can propose for that city, and more of that the capacity of that city, like a human resource or current vehicles or the fund which that city corporation or city can provide for this sector, and yeah, that type of from my small understanding, these things in the initial stage itself we have to understand for the city. Other than that, if anything important thing from your experience, if we have to understand, please share, sir.
That's very good. Thank you very much. We will take one or two more comments because obviously you will have chance in the next two slides also to discuss. So I can't see everybody, but I can see Khalid and Manisha have raised hands. So Khalid, please go ahead. Thanks.
Hello, Assalamu alaikum. Can you hear me?
Yes, Khalid, we can hear you.
Yes. From my point of view, my answer will be, first of all, designing the recycling program. We should start the scooping study so that we can able to know which type of waste is generated daily. Because we cannot design the recycling program that how much waste is, which waste is here to which thing that could be recyclable, like PET bottles or you can other thing, or aluminum cans, so that we can estimate. After estimating and collecting these data, so after that we will design a proper recycling program. That is my point of view.
Yeah, thank you, Khalid. We have quite a few raised hands, so I'm not sure whether we can take everybody's, but I will come to you. I'm noting your name, and I'll come back to you after next couple of slides. Yeah, Manisha, please go ahead.
Am I audible?
Yes, we can hear you.
Okay, from the best of my knowledge, I can say, like, first we have to see if there is already exist any recycling program or not, and then we should collect data for the recycling material, like which type of material it is, and then we can estimate the land size, how much land we will require to design that, and like container type and transport.
Okay, good. Is that all, Manisha? Thanks. That's very good. Yeah. So thank you very much. I got a couple of names here. I will come back to you in a second. Thanks for sharing your thoughts. Put it in the notes in the chat and keep it with you. So what I think that what we learned from this exercise, what we learned from your responses, if you just take a look at the chat box, we talked about quite varied range of data. So obviously here we are talking about waste data, yeah. But there is also very important data about which helps you in developing this bigger picture: population data, type of the city, streets, what the program, how the program will be designed and run. You have number of assumptions there, yeah. And you picked all those. That is very important. But in terms of waste data, you picked up some really good point. So what you saw in the previous slide, the generation rates, the composition analysis, the density, moisture, and all those traditional parameters, what we are finding, they have limited value for circular program design or recycling program design, because you collect data in a certain way and then you use it in another way. And that is a gap which I would like young professionals to think about more, that do we still need to continue with the traditional parameters and then pick up the data which we need, which is the focus of our program, or do we need to be more creative about data collection, and do we need to think about it differently? So in the next slide, I would like to share with you my thoughts as an example about what data on the waste we probably need for a plastic recycling program, right? So in this case, so the data I will be needing is percentage of clean plastics in household waste, right? So again, there's a catch here that plastic can be clean, plastic can be unclean. In household, people sometimes separate plastics, and that is clean, but some plastic also not clean. So for example, food pouches and plastic, thin plastic which comes with food, it may be dirty. So even at the starting point, you have immediately two categories of plastics, putting aside different types of plastics. Yeah, percentages of clean plastic in commercial waste. So there are shops who are generating plastics. There are markets which may be weekly, some may be monthly, some may be yearly, and the plastics also generated from there. The types of plastics in mixed waste, the volumes and waste of major plastic types in that. And here, especially, I would also like you to think very carefully always about the difference between the volume data and the weight data. A lot of environmental studies on rivers and oceans and all that. Unfortunately, we are still using weight data. And actually, for environmental reasons, the volume data can be very important, because a very thin sheet of plastic, which can weigh only 100 grams, but it can easily cover 2 or 3 meters of the water surface, right? We are not thinking, unfortunately, in those terms, but I think because we are so much stuck with the traditional data sets. And I really like you to also think about some of these things where volume data is more important, where weight data or mass data is more important. Major streams of waste at city level, plastic waste. So if you're designing a recycling program, then household is only one source. And tomorrow's session, I will be covering about city waste streams more. So what are the other streams? There may be an industry which is generating waste. There may be another source where some of the major streams. So you need to understand those. The level of contamination in each of the streams, how and why they happen, and the generation hotspots, where those hotspots take place. So the key purpose here is to identify the sources and to ensure the supplies of materials for your recycling program. one of the things which you always ask is what is the key purpose of why I'm doing the waste analysis, and keep probing about the key purpose unless it's clear. Sometimes you are told, I do a lot of data monitoring and evaluation trainings, and in many cases people say go and collect data, then we will see the data and let you know how we use it. That's not really ideal. The purpose needs to be very sharp and clear before you start your data collection exercise. So I stop here to take few more questions or comments. Maria, do you see any burning questions, or shall we go back to people who raised their hands before?
We can go to the who raised before.
Okay. So Emmanuel and Akrawat and Johnny. So Emmanuel, you want to start? What you wanted to say before?
Let me say good morning to everyone. You have addressed my comments in this present slide in terms of generation hotspots and the distance from a recycling plant. That's critical because cost of recycling is somewhat high, and if the distance is very far, transportation cost would definitely reduce on your profits. So that is critical. And level of contamination. So you are basically addressed my comments, because if your waste is highly contaminated, definitely it's going to be too costly.
Yes, I would like.
That waste.
Hello, can you
Thanks,
hear me?
Emmanuel. Yeah, thanks, Emmanuel. Yeah.
Okay, I would like to add one thing here is regarding that. I think, at least from the modest experience I have, is that the impact of the informal sector on any recycling facility can be very high. I wouldn't name a few countries that I visited in Africa where the informal sector was very strong to a point that the authorities couldn't build a recycling facility because the informal sector had a control over everything.
Yeah, so who controls the stream? That's a very, very important point. Thanks for sharing that. And then we got Akrawat.
Dr. Mansour, we
Yeah.
have one question here
Yeah.
from Bassem Soliman. He's asking, or she, sorry, why the focus is only in plastic.
Yeah, I use this as an example I think the key point in the discussion is to what extent traditional data sets, which you find in any books or publications, are useful for circular economy project designs or recycling project design. That's the question we are dealing with. And what I'm trying to say that those data sets are sometimes not very helpful, and I'm recommending not to use those data sets without thinking about the purpose. So for recycling programs, we need to be specific about what data we need, why we need. I mean, you touch already quite a number of very important issues. And I use this as an example, but you can easily think about glass or cardboard or anything else. So thanks for asking that question. Yeah, thank you. I got Akrawat and Namfar on my list as well. So Akrawat, you want to go ahead, please?
Yeah, I'm Akrawat from Thailand. I think to make a recycling program successful, we need to consider about the recycling center or shops, because if we don't have data about this, because it would be difficult to have a good plan, because in Thailand we don't have not all recycling in many products. We only have plastic and metal, but in some other type of plastic have a field value. We don't have this. So if we don't use this data, we may collect this product, and we don't have a market to serve it.
Yeah, no, that's again good point. But because the global attention is on circular economy, recycling, waste reduction, so I'm sure when you will be working more in waste sector, you will be facing some of these challenges. And you are absolutely right that at the moment, if you collect this data, people will not pay attention. But if a company comes and investing or government developing recycling program, then they immediately need some data. And that the risk is that they go to the traditional data sets. We are trained for that. So we go. So this is the difference here. Thank you very much for asking that question, Akrawan. So we take 2 more comments, and then I got 3 more slides to share with you. So first Numfor and then Vishnu.
Thank you very much. I'm called Numfor Solange. I think it's important to to segregate waste. We know this is very much practiced in advanced countries, but in developing countries, it's not very much the case. Because it helps the people to contribute, to the whole recycling process, and then collection of the waste, and the collection center, like the treatment center where they sort the various waste. The distance, someone earlier mentioned this, should be considered, and also the distance from the sorting or the collection center to the disposal or the landfill, for residues. And also it's important to also get to know the existing recyclers. Like in developing countries, we have small-scale recyclers of particular waste, because the recycling plants that you could establish might not be able to recycle all the types of waste, all the different types of waste. So it's important to segregate or to separate the various waste and then channel them to the various recycling facilities or recycling businesses. Because if we collect and then we don't recycle at the end of the day, it doesn't make sense. Thank you.
Yeah, that's very good. And last comment from Vishnu, please, and then we will move to the slide. Vishnu, please go ahead.
Thank you, sir, for sharing the slide and the new perception which you proposed. It's very good that we have to understand the volumes and weights of major plastic and everything, and the percentage of clean plastics from household or commercial space also. As of currently in the pre-work, we'll be getting some percentage of clean plastics. So, but other than that, just I am asking, if we understand the demography, or if we understand the type of households or type of commercials in a city, in that city, then we can understand that how much of waste these households will be coming, so that some other interventions, because before itself some value chain will be there. So from that value chain, if we are moving to that value chain, that will be a problematic, or some issues will be there. It will take some time. So initially, if there is an issue, or if there is if for an example, there is no source segregation is going on in that city or in many places. So if we intervene in that, and with the support of the city, if we get that, if we intervene in that, and if we get the materials from those areas, so that we have to understand the demography of that area, like that income level people, how many people, households are there, like a high income, low income. So is that an important matter or important thing in that, like including these parameters? Just I'm asking.
Yeah, absolutely. And Vishnu and Namfor's both questions, they are very important, because you start with the initial data sets, initial question, then you build on that. And as both of you said, that some of these things may take time, but also as the program develops, as the data collection exercise develops, the purpose may also change slightly during that exercise, because people, as you said, people can see there are more streams in this area, lesser streams in those areas. So all those factors are very important. I think one of the challenges we all face, we have very little budget and time allocated for these exercises, right? So if you have very limited time, then you come back and report your data, and you want to go back again to the field or do it after interval. In many cases in projects, there is very little opportunity to do that, right? Because we have not made a good case about waste data in the sector so far, and that's where I'm coming from. So I will see your questions in a minute, but let me move on to the next slide. So this is another exercise. I suggest we leave it for now, but just take a quick look that you asked why we are doing plastic. So in this case, we are saying that if you're designing a recycling program for citywide compost, packaging or metal, the point is what data set you will need, yeah? And then what we are suggesting that you pick up based on this discussion and based on the exercise, the example I showed you on plastic, what I'm suggesting you that you pick up one of these material or even pick up your own material. You can pick up paper or you can pick up metals or plastic or one type of plastic or organic material to compost, right? Or something else. And then you think about, more important is think about what data set I will need. My suggestion is that you focus first on the waste data and then related data, right? So related data, basic one, as you already mentioned, population. The other basic one are the type of settlements and all that, and you build on that. And then the third layer, you think about the variation in the data. So how the data will vary as per months of the year, time of the year, the new development coming in, some of the habits changing and all that. I suggest you put it into the third layer, right? So this is for you to do, and I'm sure you can either note it down, take a screenshot. This is not for discussion, and share with the organizers, right? Is it clear, or you have any burning questions on this one?
Sir, can you explain the question once more, what you are expecting this?
We want you, as I showed you a slide before on plastics, we want you to pick up one material from this, or a material, single material. So here you have, for example, compost or packaging or cardboard or paper or metal. Pick one material and assume that you are designing a recycling program for a city in a developing country, and ask what data set you will need, and start with the waste data set, which we need for this course, for your certificate. Then you can add other questions if you have time, especially population and areas, and what sort of variations, what are the influences on your data set. Do that. So prepare it layer by layer and submit it to the organizer. Do not do more than a page. Half a page to 1 page is great, right? And you can even share your handwritten notes, photograph, or your email or whatever to the organizers, and they will decide. I think they will need it for the certificate issue. So I think it's simple, it's clear. I suggest you try to attempt it. We go to the next one, please. Next slide. So after this slide, I will take some of your questions. Let's keep this discussion on waste data, right? And tomorrow we have another session. There are lots of other issues about planning the projects and behavior change and markets, and I suggest you keep it safe for further discussion. I'm sure there will be more training sessions organized. So the key points, what I'm trying to convey, that for circular economy projects which are on the rise in both developing countries and developing countries, the traditional data set, which is the generation rates, bulk density, and composition analysis we used to do, and if you find it in many publications, global publications, have limited value. So you can start from there, but you need to then build, you bring your data set that, okay, within those, what I need. My city generates 5,000 tons, but out of this, how much is paper, right? When you focus on paper, then you have other questions within the paper. So try not to use the traditional data set for your recycling or circular economy program using assumptions. And assumptions, we will talk a bit more tomorrow, but assumptions is the biggest killer in the sector at the moment. In many models, we are using massive assumptions. We are relying on government data and without validating. And I suggest, as young professionals, it's very important to think about this. Why I'm using these assumptions? Are these the tested assumptions or not? Second point is new tools and methods are not fully tested at the moment. We need a lot of assumptions and challenging. They are very challenging at the field level. One big challenge is the limited time, limited budget, limited awareness, limited understanding. Especially if you take a data set to the mayors or the ministers, they don't know what to do with it. So you need to think about the communication, right? And how some of the new tools help you generate new data, how you build, test the existing models, because a lot of new models are available, but there's very little reflections on what data they are generating and how much of that. I think you have a presentation from Andy Whiteman, and he's an expert in this field, that how they build up their data model. But there's need for more reflections and challenging our own assumptions, right? Keeping your purpose in mind. So if your purpose is to set a recycling program from household or a shop or industry or something else, keep that purpose in mind. Do not compromise in that. And a common sense creativity is extremely, extremely important for your data. Do not pick up a tool and start using it. Use your common sense, do your observations, and compare with what data is coming. In many cases, we receive data, but when you go to the field, the situation is very different. And you saw some of the slides already about that. And creative methods as per ground realities are needed. So these are the key points I would like to convey. We still have, I think, 10 or more minutes. I have an exercise for you to do. So let me introduce the exercise, and then we will open the floor for more discussion. And you're already participating very well in this course. So that's very good. So can we go to the homework then, please, the next exercise? So this is a quiz which you need to do later. We would like you to, based on your experience and this session, write down 3 challenges of traditional waste data collection for circular economy projects or recycling projects, right? 3 challenges based on what you heard. I think you can hear this session again if it is recorded. So just write down 3 challenges, but we'd have very good discussions already. And second question is, give one example where volume data can be more important than weight or mass data, right? So think about it more creatively, but where you will be reporting, collecting, and using volume data, how much volume this material or mixed waste will capture as compared to the weight data. These questions for you to do homework, right? Is it clear or anything not clear to you? I assume it's clear, isn't it? Okay. Now we go back to the discussion. Maria, I'm assuming we have 10 minutes, so I need your help and others' help to facilitate the questions. I can't see everything in the chat box, but if you have any questions, you can raise your hand, you can write down in the chat box. You can even share some comments about this, this topic, but remain focused on the data sets at the moment, because this is the topic we would like to discuss and learn more. So thank you very much. The floor is open now. Thank you.
Dr. Mansour, should I stop the screen sharing?
You can do it now. Yeah, thank you. Yeah.
All right. We have a raising hand. So Dr. Mansour, would you like to just take the raised hands?
Yeah.
Or
and keep an eye on the YouTube as well, so we can take raised hands.
Yes, we're
everybody
keeping an
has
eye
equal
on there.
priority. Yeah, whether people attending YouTube or this session or raised hand, everybody has equal priority. We got enough time to discuss a number of questions. So Vishnu, you want to share your question or comments? Please go ahead.
Hi, thank you for sharing this valuable information. So I just want to ask you that, so from your experience, what all like challenges or what all things we have to improve as a developing country, from developing country perspective, asking we have to improve for making a circular economy in our sector, in the waste management, from your experience. Can you share some experience in the field level which you have gone?
Yeah, thanks for asking this question. I think that, probably you ask about how to improve circular economy in developing countries. So quite a lot already happening in countries, and there is a lot happening in terms of what is already happening in terms of small scale, informal sector. I know some of the organizers working on some very interesting projects. You improve that. I think what I am trying to do in one city, at least, we are also developing a city declaration about the circular economy, because sometimes the city are very, when they're blind, they are not aware, the city decision makers. So newspaper articles, papers, webinars really help. A lot of cities focus on waste collection and disposal sites, because disposal sites are in short supply, they're not available, they're very expensive investment. And then the vision of circular economy very much is the investment of a big MRF or a big industrial plant. We need to move away that thinking from a more systemic approach. I think somebody mentioned about the value chains and the prices. So how we bring the whole system into that. And some of the work happening in India, for example, on EPR is very, very interesting because it has links with the circular economy. So those are some of the quick thoughts on this. But as I said, try to focus on the data sets for now. Yeah. Thanks for asking this question, Vishnu. Okay. Next, any other question? Thank you.
Just letting you know that there's no questions on YouTube to I'm not sure if you can hear me. Hello, are you able to hear?
Yes, Maria, I hear you.
Yes.
All right, perfect. Sorry, I technical issue, something got just frozen. We have a question from Zahil Iktabal, and he is I assume it's a more common than a question, that volume is more important to design and development of machinery for collection or storage, etc. Yes, and then I think that's okay. We have Shiza writing, commenting, because I cannot see actually YouTube comments. Oh, Dr. Mansour has dropped out. All right, so we just have a little technical moment, then maybe Dr. Nasur, we will get him back meanwhile. But Hania, just let me know if you can't hear me.
Sure.
Right? Yeah, I hear. But thank you everyone for such active participation and such a great questions and your input. It's really, really interesting, and also to have this discussion because we are right now from all over the world to hear sort of different perspectives, because we are all having different waste management systems. Some are more advanced, some are a little less advanced, so-called, but there is tons of opportunities to work in and to research and to develop and think outside of the box, right, Hania? Hania, would you agree?
Yeah, sure. And
yes. Dr. Mansour, we are getting him back now. It's okay. Now we're getting him back. Dr. Mansour, can you hear us? Yes.
I can
Welcome
hear
back.
you. Sorry. Yeah,
It's
my
okay.
internet was down. I hope there are no other questions.
It happens. It happened also to me this morning. So it's such a normal thing. But let's get back to the questions. We have one question, for example, from the YouTube, and Maitiri Ramwala. Apologies for butchering the name, but person would like to ask on your perspective on the cleanup drive. Is a reliable or including citizen and behavior change is important. I don't know if that's a question or a comment, but I guess the cleanup drive and including the citizen and in the behavioral change. That's yeah. I don't know if it's a comment or question.
No, we try to link these questions with data as well, yeah, because the cleanup drives are very important. They can lead to something which is more sustainable. The best program I came across in my career was a program in Nepal, which is not really documented because this guy was an entrepreneur and he was covering something like 15,000 units in those days. He was charging a fees, and his team was starting with the cleanup drive in the area. So they go and clean one area, a new area, and they say, now we have cleaned this area, you have a service available, and you pay us a bit and we will continue. And I really like it because it was not depending on any donor or government money. And he was continuously, so this was his business approach. So if cleanup drives are for awareness raising or doing a sustainable business, they are good. You know, you can collect the beach cleaning, you can collect the bottles and plastics, you can show to people, you can put the pictures in the newspaper. It helps in behavior change. But cleanup drives for solving a problem, I don't recommend, because they just solve a problem, but then people become dependent on cleanup drives. So that is my view on that. Thanks. Thanks for this question. Yeah, good question. Another question? Yeah, please unmute.
Yes, we have from Christian Cano in the chat. He's asking, what do you think about textile waste data collection, and what specific issues do you see there? Personal interest of mine, because because I work on the projects of textile waste.
No, that's very emerging area. I think the textile waste from markets and post-industrial textile waste, a lot of work I've done in cities of Pakistan, and what we found that a lot of post-industrial textile waste, which is pieces, it's all picked up and reused in a big way. Some of it even is a fuel, but some of it reuse for different purposes, and from markets as well. In developing countries, the separation of textile or clothing is not a very common practice, because there's always a group of housemate or house support or another group who takes and use it. So when they become very, very old or unusable, then they only go into the mixed waste stream. But but I think again, it's very good example. Textile is a very good example for this session, where you don't start with the mixed waste stream. You don't start with the traditional data set. You look where are the streams, where I go and find the textile waste, and you build your picture from there. So thanks for raising that. And I don't have any experience on textile waste, but I have some views on this. Thank you. Okay, next one.
Is it my turn?
Yes, it is.
Okay.
Yeah, go ahead, please.
Yeah. So Dr. Mansour, now that there is less question, maybe I can ask two questions. Sometimes when we want to start a project and we go to a place, especially in terms of developing countries, the data that is available is too old. So we cannot trust this data. So going to the literature, we may see some articles that are suggesting, for example, 1% of waste projection for each year. Or there are several equations that are relating, for example, there are some equations that are relating parameters such as like number of collection day or the height of a place to project the waste generation. Do you suggest to use these or is there at least a rule of thumb rules so that we can imagine how will, if the data is for 10 years ago, today at least I should estimate how much waste is generation? This is the first question. Afterwards, I will ask the second question about the composition. Thank you.
Yeah, thanks for asking this question. It is a common issue. It is something which we all face, and I suggest the basic one of the key causes of this issue is there is a lot of debate on what exactly is the population of a town or a city, because these things are very political in nature, and there are very little agreements on that. So rather than go into that debate, you need to talk to key informants and agree. What I do in my assignments, I pick up a set of 10 to 20 key parameters, and I fix them at the start of the assignment. So we don't keep changing them, right? So I said, okay, for this city, this is my population assumption. Now, as I said, assumptions are not great, but in some cases you have to start to set up your basis, but later you can avoid as much as possible, right? So key parameters are established, and after that you use the traditional method of what increments are possible. I think the basic data is one thing. You can establish that, okay, in 10 years time, what has changed, this and that, but the narrative commentary on that data is equally important, and that's what we miss. So how the city has changed, how the festivals have changed, right? What new waste generation streams are coming. For example, in one city I'm working for many years, there's a very big increase in delivery food, right? But no article or no paper or no debate talks about that. So a lot of hidden streams appearing. And this is the topic actually for tomorrow, and how we deal with them. So that narrative summary of the variations, possible variation, hotspot, the catch points, those in my opinion are very, very important. And if you develop both of them, then you have a good case for working it further. So I suggest that's how we can move to the next stage. But as I said, nothing is ideal in this sector, in this topic, because a lot of gaps are there. You pick up anything, there are lots of gaps there. So, okay, thank you. Any other question in the chat box? I think we used our time, but we can take a couple more questions.
No, we're not over time. We actually have 7 more minutes. So it's perfect. And I know that Hania had a composition question, but if it's okay that there's a question from YouTube, from Mohad Huzaifa, and he's asking about how to bring a behavioral change for circular economy. Big question.
I'm trying.
But important.
As a rule, I'm trying to change all your questions as per topic of the discussion. So I will say how the data can help in behavior change, if you allow. Sorry about this, but I'm not expert on everything, and this session is not about everything in solid waste management. So I think data has a very big value in behavior change. If people, in many cases, people don't know what they're generating. In many assignments, I ask people where their waste goes. 70 to 80% people don't know where their waste is going. We recently completed one thesis, MSc thesis, and they asked in low-income areas, they're asking, do you know where your waste is going? A collector is coming and people are taking, and they really, so there's very little understanding of what we generate, how much we generate, and where it is going. So data is a very strong tool, and how you present it, not as boring numbers, but as strong visual tools. That is very good. There are lots of examples from sanitation, mapping, and CLTS and others, which also tells you that how data can be a strong trigger for behavior change. So yes, answer is yes, and be creative about it. Okay, good. Thank you. Next one.
Is it okay, Hania, that I take one more
Yeah,
from the before we get? Yes, so we have
Almost answered.
Buguya Ariele from in the chat, and person is asking, what do you think about the determination of emissions factors in the landfill in Africa? Is it easy or wrong?
That's no expertise, sorry.
All right.
I don't want
But,
to say things which I don't know. But
okay.
I'm sure in this group there are people who can answer this question. So.
Yeah, that's right. You're very welcome to answer. But Tanya, would you like to have the composition? And I
have a lot
data
of regarding the data for Dr. Mansour. So Dr. Mansour, again, in the case of city, when we want to start working and there are not a lot of data, what do you suggest to go like to establish a good phase and start to working? Because sometimes a very big thing that is missed is the waste that is coming from commercial sector. Nobody knows anything, and it's just collected, even the amount of the waste and everything. And because there is more money, like I don't know, to handle it. So the importance of what I could suggest, I want to ask about the importance of data. Should we pay more attention to gathering data from different sources, or how does it work? Is it a stepwise? You suggest that we look at it as stepwise, giving more importance for collecting data, or we can have one of the stream data and we estimate the other part from the data we have.
Yeah, no, this is very relevant. Again, we will be discussing tomorrow a bit about it. So my first step is in many cases, especially medium to big cities, we don't know how the system is operating. Where are the waste streams, right? We know about household waste. We love to test the household waste, but that's not always right. So an understanding of the waste streams and where the waste is generated, understanding of the system. In a city, if you ask where the waste is going, people will say 5 landfill site. Another key informant would say 50 landfill site. Another one say 100 dumping site. So there's a lot of confusion. So you need to establish again how the system is operating, then focus on key points where useful or relevant data is available. And the other thing is, I'm not going to answer everything because it's a topic for tomorrow. But one more thing which in the discussion, Shiza, is city authorities should take the responsibility of core data sharing with the citizen. So if you can create that through, I don't know how it is possible, because UN Habitat is doing something which is quite interesting to this, that city authority take the ownership of the data through the city authority website. Some core data may be available, and they take the responsibility of monitoring it regularly, not using lots of resources, but something which is help citizens to understand. Like citizens like to know how much water my city use and all this. Similarly, waste data is very neglected. But the other thing which we are discussing also is what other data is important. Because at the moment, a lot of data comes from 2 or 3 sources. So data comes from projects, and when the project's finished, the data disappears. So there's no collective database of how much data, what data is there, right? That data comes from theses also. So students' thesis, there's no compilation of those theses. One university is trying to do it, but their own thesis, right? But across the universities, many studies happening, and I feel those are very unbiased, good, sometimes good quality data as well, right? Some PhDs as well. And then the project in the city. So if we combine these 3 dots, the city level basic data, the project to project data, and the research generated data, I think you will be able to create a picture. But in any case, I think most important thing is that the city authority needs to take some ownership and responsibility of that data. I feel that is very important. And additional data you can build on. So that I can share for now, but again, we have a discussion tomorrow on this. Thanks.
That was a very good point. So I will keep in mind during my project, I will suggest that the university works together in the link with the municipality and city to compile the data. That would be also a source of useful source of data.
Absolutely.
Thank you.
Yeah.
You're on
Any-
mute, Dr. Mansour? Yes.
Any other topic of questions? I'm available, but it's up to you. Yeah.
Yeah, there is some more questions to you, but unfortunately we run out of the time. So Dr. Mansour, thank you so much for today's session. You mentioned about the UN Habitat. That's a very smooth transition because we take a 10 minutes break and we have someone from the UN Habitat for half an hour going to be talking. So thank you, Dr. Mansour. Thank you for everyone participating on this session. Let's take a 10-minute break or 9-minute break now, and we will be back to this. Thank you.
Thank you. Thank you. Keep in touch. Thank you.
Hello, everyone. We have less than a minute left of our break, so if you need to get a cup of water or anything like that, hurry up. We are continuing our session. Well, it's 10 past here. I assume it's probably, yeah, let's just start up. So warm welcome back to this session. If you haven't been in other session, my name is Maria Jäppinen and I'm coming from the Lab University of Science from Finland. But anyhow, we have a great honor to go all the way from, at least from here, from this point of view, from Finnish point of view, 10,000 kilometers to Kenya. So we have from United Nations Habit, Waste Management team representative, Mercy Achieng. She is a community support officer. She's a waste management specialist with a background in the environmental law. And today, for next half an hour, she will be talking about Waste-Wise Cities tool. And then afterwards, we're going to have a 10-minute 10 minutes of Q&A session. So if you have questions, please put them in the chat on the YouTube or here on the Zoom. Can Mercy hear? And yes, you are right here. Are you able to share your slides? Very nice to see you.
Nice to see you. Can I ask, thank you, Maria. Thank you, Dr. Munsu, for the presentation with active participation. I would ask for you to share my slides.
All righty. So, okay, no worries. We have a sheet. I think she's working right on it to share it, or then Hania. And little technical moment.
Yeah.
Thank you. They're working on it.
So, Mercy, you want me to share it, or you want me to allow you to share the screen?
Share the screen. You can share the screen.
Give me a second.
Do you need to share the screen also, Maria, for this session?
I personally probably, I think Shiza is working on it.
Mercy will share, or?
Okay, let me
I'm just downloading the presentation.
No worries.
Okay, I have it now. Okay, I'll share.
Okay.
Wait for the screen. Too many options here.
You want me to share also?
Yeah, Hania, you better you do it because I have too many options to do.
No problem. I will share it right now. And then download. Okay. Share the screen. Let me. Okay. Okay. Is it the PDF, yeah?
Yes, the PDF.
Okay. Here you go.
Thank you.
All right.
Yes, my name is Mercy Achieng. I work with the UN Habitat Waste Management in Nairobi. And today I'm here to represent my team and present on the UN Habitat's Waste Management Program using SDG Indicator 11.6.1 as a central tool to catalyze actions in the cities. So if we start, next slide, please. Next. So if we look at the world globally, global scale of urbanization and economic growth is creating a potential time bomb in relation to the waste we generate around the world. If not addressed now, the negative impact of human health and environment will affect nations and level of development. So with this, if you check the screen, we have an estimation of 2 billion people globally who are lacking access to the solid waste collection. 3 billion people are lacking access to controlled solid waste and disposal facilities. And urban dwellers, especially in low and middle income countries, are exposed to serious public health threats due to poor solid waste management. And uncontrolled landfills are already a major source of greenhouse gases. And if we continue in this path, food waste will project 8 to 10% of the greenhouse emission gases by 2025. It's estimated like that. So the next slide, please. Yeah. In addition, each year, 11 million tons of plastics are dumped into the world's oceans. Next slide, please. So this is an estimation of African waste generation projection, okay? So sub-Saharan Africa is the fastest growing region, with the waste expected to nearly triple by 2050. If you check the graph, the blue bar represents the waste, the generation projection in 2016. The orange or yellow one, depending on what you see, is an estimate in 2030 to come. And the gray one, and the gray one is the expected one in 2050. So as you can see, sub-Saharan Africa is growing faster. So next slide. So to address this global waste management issue, UN Habitat launched a program called the Waste-Wise Cities. I had the previous presenters mentioning it. This was launched in 2018, and we now have more than 290 member cities around the world. And from the private sector alone, we have 72 organizations who has joined as affiliates. Next, please. The main aim of the Waste-Wise City is to improve waste management and resource efficiency in cities around the world through four action areas, as you can see in the 4 boxes. So the first box is knowledge and good practices sharing. Second one is waste and data monitoring through the worked tool. The fourth one is advocacy and education through the online courses. And 4 is project finance and support for bankabilities. In the second area, we are monitoring the SDG indicators. It's in the next slide. Yeah, so African Clean Cities Platform, its inception, is an African regional focus program which was established in 2017 by the support of Japanese government. It is knowledge sharing and an infrastructure investment platform for African cities. ACCP assembly is held every 3 years to discuss the direction of platform activities, and UN Habitat is hosting the Secretariat of ACCP since 2019. Currently, we have 161 cities from 144 countries in African continent. So ACCP is for African cities. Next slide. Action areas are the ones here: knowledge and sharing networks, promoting the achievement of waste SDGs targets, and the third one, supporting project developments in waste management. So if we check the SDGs in the next slide that we are monitoring, so these SDGs are waste related. So if we check SDG 11, which say goal 11, which makes cities and human settlement inclusive, safe, resilient, and sustainable. Also goal 12, which ensures sustainable consumption and production patterns, and goal 14 that talks about conserve and sustainability use of oceans, seas, and marine resources for sustainable development. So let's go to the indicators in the next slide. So UN Habitat is the main custodian agency monitoring goal 11, target 11.6, which says by 2030, we should reduce the adverse per capita environmental impact of cities, including by paying special attention to air quality, municipal, and other waste management things. The indicator here is the proportion of municipal solid waste collected and managed in control facilities with regards to the total waste generated by the city. To monitor the indicator 11.6.1, UN Habitat developed the Waste-Wise Cities tool, the WORK tool, and it can also measure the other waste-related targets, which are 12.3 for food waste, which says by 2030, half per capita global food waste at the retail and consumer levels and reduce losses along production and supply chains, including post-harvest losses. The indicator is the food loss index and the waste and the food waste, and the food waste index. When we go to 12.5 is for national recycling rate. So 12.5 says by 2030, we should sustainably reduce waste generated through prevention, reduction, and recycling and reuse. So this indicator is national recycling rate, tons of materials recycled. And the last one is goal 14, target 1, which is for marine litter and plastic leakage. So this is the index of costs for the plastic in the oceans, the density of plastics in the oceans. Yeah, so next slide, let's talk about the Waste-Wise Cities tool. So what is a Waste-Wise Cities tool? So WORKT is a monitoring methodology of SDG indicator 11.6.1, which says measuring proportion of municipal solid waste collected and managed in control facilities. So out of the total municipal solid waste generated by a city. So this tool helps a city in which way? So this tool helps cities to assess the municipal solid waste generated, collected, and treated in controlled facilities. It also identifies the municipal solid waste recovery chain and its actors while engaging them in an inclusive and participatory way. Also, it checks the environmental control level of waste management facilities, establishes better waste and resource management strategies, and create business and livelihood opportunities. It provides data for large waste infrastructure investment cases to municipal corporation. It helps the cities with the data. And waste stakeholders and investors also use this data. Yeah, the last thing it does to cities, the last way the work to help the city is to project development and funds mobilization. So let's see what WORKT measures in the next slide. Yeah, so what does WORKT measure? So this diagram here is what WORKT measures. So let's say this is a total municipal solid waste generated by a city. Some of them are collected and some of them are not collected and are hanging around in the environment. For example, in the rivers, in the slums, in the nearby lands. among waste collected, some of them go to the recovery facilities and some go to disposal facilities, which are the dump sites. Those facilities can be categorized as control facilities or uncontrolled facilities according to the operational environment control criteria, which is also in this Wastewise City tool guide. If you, I'll show the link at the end of it, and you can access everything there. Also, there are material flows between recovery and disposal facilities. Residues and rejects from recovery facilities are going to the disposal facilities, and recyclables are often recovered from disposable facilities to the material recovery chain. So what we measure here is the municipal solid waste received by controlled facilities, plus municipal solid waste received by controlled disposal facilities. And then we subtract the residue from the controlled recovery facilities and recyclables recovered from controlled disposal facilities. Then we divide it by the total of municipal solid generated by the city. That is the percentage of municipal solid waste collected and managed in controlled facilities out of the total municipal solid waste generated by a whole city. This formula can also be got in the step-by-step guide of the worked tool. Next slide, let's see the steps of the Wastewise Cities tool. So Wastewise Cities tool is divided into steps. So before you apply the worked tool in a city, the first step is the preparation, yeah? So first we have to get approval from the city and proceed with the logistics coordination with the stakeholders. And then in the second step, and the third step, in the second step, we do the household, municipal solid waste generation and composition. Third step is like the second step, but here we do waste generation in non-household facilities. In step 4, we visit the recycling centers to conduct some interviews and check the level of controls. Step 5 is almost the same as step 4, but we visit the final landfill and we go to a landfill or a dump site and we do waste composition from the trucks coming inside. We pick trucks from different income level households, yes, areas. So step 6 is the waste composition at the disposal sites, yes. And then step 7 is the last part where you enter the collected data into a worksheet of the tool. It's called DCA. So if a city is a small population, we can do the 7 steps in 3 weeks. But if the city is big, we do it in less than 2 months, but normally 1 month is quite enough to do a worked application survey in a city. So let me give you example from where we have applied worked. So next slide will show you where we have applied worked. So we have applied worked in Nairobi in Kenya. Nairobi is the capital city of Kenya. So from the worked survey tool that we did, Nairobi generates 3,000 tons of waste per day. So every day, 460 tons of waste is sent to the recycling centers, and 1,550 tons of waste is sent to disposals daily. A lot goes to the disposal. There are many waste pickers in Nairobi who collect a total of only 40 tons of recycling materials from the landfills. This is what they recover. And the recovery process generates 50 tons of waste. These recycling centers in Nairobi, a level of control is categorized as controlled. Therefore, and 100% of the waste treated in the recovery facilities is managed in controlled manner. And so 1,072 tons of uncontrolled waste per day. This uncollected waste is uncontrolled. The uncollected waste in uncontrolled disposals can be source of plastic leakage. The left one, that of the plastic leakage, and of the other sources of the other leakages. However, based on our results in Nairobi, it was estimated that 4.5 kilograms per person per year of plastic leaks into the water bodies from municipal solid waste system. The amount of uncollected waste, Machu Picchu would be buried in rubbish within a week. So they can be categorized as waste managed in control facilities, which are also privately owned. So the next slide will show us the flow of the waste. No, not that one. No. Okay, so no, the burning landslide. Yes, these photos here are showing the burning dump sites and full of waste. In on the right, on the left side is Dandora dump site, the biggest dump site in Nairobi. It's always burning with waste. And on the left side is a river full of waste. The next slide, please. So this was a picture after a successful stakeholder workshop in Nairobi. So after the survey and the data and analytics in Nairobi, we organized this stakeholder workshop, inviting NGOs, private waste operators and companies, waste pickers, and so on to discuss the issues based on the work results that we got and to identify what kind of actions are needed to be taken to improve the solid waste management system in Nairobi. Next. So through the workshop, Nairobi developed the future waste plan flow, and it was adopted as Nairobi City County Sustainable Waste Management Action Plan. That is what the city developed. And next, I'll show another, next slide, I'll show another example of a successful works tool in Kenya, but Mombasa City. Mombasa is the coastal city in Kenya. So this is another sample from Kenya, Mombasa County. Before we applied work in Mombasa County, waste management officers were thinking that the municipal solid waste generation in Mombasa was around 2,000 tons per day. Therefore, county needed to set up waste to energy plant. However, the fact was different after the work tool was applied. So as you can see, in the total county, we realized the county generated 780 tons waste per day, not like before, not like they thought 2,000 tons. And totally 36 tons are recovered in control facilities and 363 tons are disposed but treated in control facilities. So all things considered, the collection rate is 56 and the SDG indicator in Mombasa, SDG indicator 11.6.1 is only 5%. So the next slide. Next slide shows this was the stakeholder workshop in Mombasa after the work tool was applied. So same as Nairobi, Mombasa organized the local stakeholder workshop and identified the policy and infrastructure investment gaps and the development future waste flow. So based on this future flow, the waste management officer reached out to many potential donors, and then this approach was successful after they showed the real problem on the ground. So the next slide. So this the work action in Mombasa led to this. The Coca-Cola Foundation and WWF brought investments to set up material recovery facilities for waste collection, coverage expansion, and also for capacity building in community cleaning groups. European Investment Bank also did a feasibility study on refuse-derived fuel factory as well as MRF establishment. So next slide will show worked applications. So this is the data portal of the Wastewise Cities tool. You can find cities and data on this portal if you use the link. Next slide.
Mercy, I must say that we are running out of. Oh no, sorry, 5 minutes. Sorry, my bad. 5 more minutes, please, and then we run out of
I'm
time
sorry,
for
I'm about to
Q&A.
finish.
Thank you. No, apologies.
Okay, so far, based on our monitoring of the SDG indicator 11.6.1, global estimate is generated, as you can see. The orange part is municipal solid waste managed in control facilities, and the green part is collection recovery. It can be said that sub-Saharan Africa, more than 80% of municipal solid waste generated is mismanaged. Next slide. Next. Yes, so this is access to basic collection services. So furthermore, from the aspect of urban basic services, there is a big challenge in slum areas. As you can see, more than 90% of slum dwellers has no access to basic waste collection services, while 30% in non-slum areas. Next. So these are the cities that WACT is expanding to, and with the partners. I cannot read everything, but we are expanding some approach to more than 30 cities from 2021. We are collaborating with partners. We have also developed a city waste portal, data portal, where all the data collected and analytics are published and shared online. We believe that Waste-wise Cities and African Clean Cities platform will contribute to monitor the progress on both plastic pollution and greenhouse gas emissions from municipal solid waste management sectors. This will encourage evidence-based decision-making and infrastructure investments in improving municipal solid waste management, especially in cities in low to middle income areas. Next slide is, this is the last slide. And these are the resources. If you need to know about Waste-wise Cities, you go to the website link below. If you want to know about the tool itself, there's a link. And if you want to check about the data, there's also Waste Data Portal. All the information is here. You can all access it. Thank you for your time. Thank you.
Thank you so much. And we have a lot of questions here coming in because thank you on a great presentation and such an interesting topic and what the Waste-wise Cities are doing. Starting from the YouTube, there is a question from Mausa Kolipali. Person is asking, I would like to know how to estimate the informal waste pickers in developing countries where there's no data. Is there a method to do this estimation? Do you have a questions on that? Oh, yeah, answer.
Was the question how to estimate the number of
waste informal waste pickers when there is no data available?
This is not easy, and this question I would also leave it on the floor to Dr. Gat and Dr. Mansour if they have inputs. If they have any inputs on how to do it, but I don't think it's not easy without the data unless survey is done to get the number. Yes, they don't have organizations that are registered. Not most of them don't have, so it's not easy to get the number. But if a survey is done to get the total number, we would get numbers. Yes.
I've heard that if I remember right, in Brazil there was conducted sort of the survey to get some kind of number, because it's hard to get any sort of correct data, so forth. But it's an estimation. Has there been any such done in Nairobi, for example?
Not that we know. Not that we know. They have groups where they register themselves, but you cannot know the exact number.
I think I have a technical. Hello?
Hello?
Oh,
We hear you, Maria. No problem.
Apologies.
We hear you. Hello?
All right. Okay, I guess there was a technical on my side. Anyway, then we're continuing to the next question from the Zoom chat from Diana M. Mazorka. One is that what are the minimum requirements for this? Yes, what are the minimum requirements for the city to apply the WAST tool in terms of data? And there's, for example, and then the second question is that how are the different steps of WAST tool financed? The city must finance them all. That's a question. And will United Nations finance? Question mark.
Okay, so the requirements to have Westwise Cities tool applied in your city, you can find that if you check on there are many requirements. You can check the Westwise Cities tool step-by-step guide. It's all there. And it depends on the finance part. Like now we have DIY works where the city is financing part of it. You must have a budget for this, and then with the budget, the city can decide what they can finance and then what UN Habitat can finance. So it can be 50-50. It can be different with different cities and their needs. Yes.
And then there's this finance part. Do city finance themselves, or UN will finance or have a contribution?
UN will have a contribution by sending a team with tools to work with the city to apply the work.
All right.
Yes.
Then we have a question from Paul Sanders. I will be interested in a rough cost estimate for the 7 steps in the middle-sized city, taking about 1 month in the UN Habitat is doing following the methodology. So I guess the rough cost.
Hello? Hello?
Yeah, I think Maria has a technical issue.
Okay.
So
Hello?
Yeah, Maria is back. Now we
Hello.
can.
So
okay, Hania, can you take, it seems like my internet is breaking. So Hania, could you please ask the questions from the chat? I think it's technical issue.
We are hearing you. Go
on my
continue.
side.
So this budget is different with each city and different with each currency. If I would give an example of a city that I'm going to apply work next week, is a small city in Kenya called Homa Bay, and we are partnering with them. So there are things they are going to finance. For example, they're going to provide like volunteers and transport and other things. And UN is bringing tools and the team. So this budget, my budget is roughly 500 USD. But this, if I convert this from Kenyan shilling to dollars. Oh. Yeah, it's about 500 to 600 US dollars that we are going to contribute as UN Habitat to the Homa Bay city to apply WACT. This is different from each city and each town and each country. Yes.
Okay, thank you. Then Shiza, do you have a question? Yeah, I see you.
I just wanted to add that it really depends upon city to city. When we applied in Karachi, so since Karachi is mega city with the population of 22 million people, and even from the size of the city from a kilometer wide, it's really massive. So compared to some of the cities, let's say if we apply that in secondary city or small city, the budget would, or the requirement for financing would be reduced compared to Karachi. So for Karachi, it was rather expensive, I would say, around 20,000 USD. Yeah.
Yeah, it's different in each city. Yeah.
We have another question here in the chat, and let's see, Mercy, if you are able to answer this, or maybe this is to the question to Dr. Mansour, maybe, or Dr. Gerd. So the total municipal solid waste you presented includes both collected and uncollected waste. How do you estimate the amount of uncollected waste when you find the litter around the environment and in the water streams? Do you have a saying on that?
Dr. Mansour can take this one, or Dr. Gad, let's hear from them first.
Can I add a short notice? Maybe Shiza also can add it, but I think in the last, Shiza may add better to it, in the last step of the VACT, when we use these tools for estimation of the plastic waste leakage to the environment, you are giving like several parameters into that steps, and the fact sheet will generate estimation for you that per person how much waste is leaking, how much plastic is leaking into the water bodies. I think tomorrow and Divide will also speak about that, right, Shiza?
Yeah, we will also speak about more, but also I think I can talk a bit from a WACT perspective. So just to let everybody know, I was part of the UN Habitat team before Mercy joined in, and we applied like in Karachi. So as Mercy informed, when they were applying the WACT in Mombasa, they initially had the assumption that waste collection might be up to 2,000 tons per day, but when they applied WACT, it turned out to be 708, something like that, tons per day. And in Karachi, we had similar case. Municipality were assuming that their waste is around 15,000 tons per day, but when we did WACT, we applied WACT, it was turned around to be 12,000 tons per day. And then how we differentiate or how we categorize how much is being collected and not collected. Under the WACT or SDG 12.6, we assume that everything that's going to the landfill, official landfills that the municipality recognize, that could be a dump site too, but anything that a municipality recognize as a disposable site. So whatever the quantum of the waste that is being received at the very end, we only consider that as to be collected. So if anything that is not reaching to the end disposal, officially recognized, we count that as
uncollected.
So, yeah, so in terms of when we applied the WACT in Karachi, it turned out that we have a collection of as much as 81%, which was rather surprising given the state and the waste we see on the sites. But there is also a limitation, I think, and that also corresponds to the question of waste pickers or the informal sector, that the WACT doesn't really differentiate between the collection being done by the official municipality and the collection by the informal or the small scale service providers, because a lot of time they would bring in their waste and they would maybe dispose that into the secondary bins or maybe at the transfer stations. So that was one of the observation we also noticed while we were applying WACT in Karachi. So I think WACT has a very clear methodology to differentiate what is collected and what is not collected in that regard. The rest, I think we can ask our Day 2 trainers from their observation, because we also have different other methodologies.
Yeah.
Maria, if you have any other
Thank you so much for the insight. Yeah, we have one more question, and actually for one more minute we are of this session. So Chepo Mokadi is asking, and also thanking Mercy you by your reflections and comments. And the comment will be on the projections. So what factors do you consider when conducting the foresight, population or operations? And this is question, Mercy, to you. Though, Shiza, if you want to answer, you're also welcome to add.
What's the what? What? The question again?
It's written in the comments.
Okay.
So on comment, what will be on the projections. What factors did you consider when conducting the foresight? Population or operations? So Tsepo can open the mic and maybe reformulate if the question.
I see the question is referring to the very first slide of yours where you showed that in 2050 the expected waste is that much. So the person is asking what that numbers are based on. Is that based on population size or some consumption and behavior patterns or otherwise?
I think population size. The first slide clearly talks about the population.
Mm-hmm.
Yes.
All right. I think there's one more question, the practical question from Christine, who is also thanking for the presentation. And the question is, can anyone use the WACT or only UN Habitat staff? Do you provide training?
Yes, we provide training, and the tool itself is a training because it has guides and steps. You can follow the step-by-step guide, and we can offer training. And some cities with the skills, that can learn it, can apply it. It's possible. Yes.
Right.
Yes.
And can anyone use the or only UN Habitat staff?
Cities can use this WACT tool.
Okay.
They can be members of the Westwise cities and they can use it.
Maria?
Yes.
Hello, sorry, this is Flavio. I'm one of the trainers, so my session is tomorrow. I just wanted to add a few things, maybe, if you don't mind, for 1 minute, not more.
Thank you.
So yeah, I've been working with the Waste by Cities team in 2021, so I'm quite familiar with the WACT and the other methodologies. So I encourage everybody to join tomorrow's session as well, because we will be presenting more about the methodologies. But yeah, just maybe to add a little bit to the answers and to the questions which were raised in this session. So yes, absolutely. I mean, the Waste by Cities tool is methodology is available on the UN Habitat's website. So I encourage everybody to download it. Last year, when 2 years ago, when I joined UN Habitat, the methodology and the tool was already completed. So being an expert in waste management and reading that document, everything seems to be very clear. So it's an easy document. I think the complexity comes from the many different details, but I think everybody should be able to understand it. And you are free to download it. You are free to use it. And it's really a nice tool. And maybe one more comment on a previous question about the uncollected waste, and maybe this is also linked to the projections. So basically, during the different steps of the Waste by Cities tool, for example, during the household waste generation and composition analysis, yeah, we also calculate the waste generation rate per capita. Yeah, so from the sampling, from the survey areas. So knowing the total population in the city, we can extrapolate. Yeah, so we will know how much waste is generated from household sources. And then from the non-household sources, we also collect data from different non-household premises. And then we also collect data from the city with respect to the number of premises, different premises in the cities, their scale, size. So then we can also extrapolate, yeah, based on the sampling, based on our survey areas, we can extrapolate the total waste from non-household surveys. So we have the generation, and then we can go into the system. So we will, from the other WACT steps, we know how much waste is being recovered, how much waste is going to the disposal site, and then the remaining, the difference between generation, what is recovered, what is disposed, is the uncollected waste. And then the beauty of the waste-wise cities tool is that it's working very well with other methodologies, such as the waste flow diagram. So all the data gathered with the WACT goes into the waste flow diagram, which then assesses the uncollected waste and the different leakages into the environment, right? The different sources and so on. So the waste flow diagram is an observational based tool, and you will be able to see at the end of the assessment how much waste is going into the water bodies, into drains, and then other areas. So you will find out more tomorrow, I think. So thank you.
Thank you so much, Flavio, for adding up.
Thank you. Yes.
Thank you, Mercy, for your great presentation. I know there's a hands raised and there's some questions. Apologies, I think we're running out of the time now. Shiza, would you like to close up this session with Hania? And on my behalf, thank you. And I'm closing my camera.
Hania, it would be great if you can close the session.
Okay.
I'll do it tomorrow.
Sure. So thank you, everyone. It was, as we expected, it was a very fruitful and informative sessions online course. We had successfully finished the first course. Thank you to all our presenter and all the participants. Tomorrow we will start the session like today, 8:30 we will start. Those who are joining sooner will be entered into the Zoom, and after 100 people joining the Zoom, the rest will, can watch the presentation through YouTube channel. Tomorrow we will also have more interaction during the presentation. You will have your task, and don't forget to participate and also fulfill the task in order to receive the certificate. After finishing the course, also we will send the presentation to you to have the presentation. Please, if you have any question, I saw that some people have a question, you can write us with this assignment, also put in your emails to ask some of the speakers if you have questions. That's all for today. Thank you, everyone. And I am closing the session for today. Have a nice rest of the day anywhere on the world that you are. Bye-bye.